Okay, so this is the first part of this section, and we're going to talk about exact equations. Okay, so the first theorem is we have two functions, m and n, and they are both in terms of x and y, and they're continuous, and they have continuous first partials. The differential equation, m plus n dy dx equals 0, or it's most usually written with the differentials, m dx plus n dy equals 0. So it is exact if and only if we have the partial of this m function with respect to y is equal to the partial of the n function with respect to x. So going on, we have a definition that we need to learn, and it's if we have the same differential equation and it's exact if there exists a function such that the derivative of that function is equal to m dx plus n dy. That's basically this left side of the equation, okay? So if the derivative of that function is equal to this, which is equal to 0, so I'm gonna go ahead and write that, that's equal to 0, then I'm thinking if the derivative of a function is equal to 0, that function has to be what? A constant. Okay, so we'll come back to that. So we have a note here. So our note is that pretty much this function that we're going to find will be another magic function that will help us solve the equation, the differential equation. So if we take our equation, which is equal to 0, or dE, and we're going to go ahead and let f of x, remember that's the partial of f in terms of x, equal to our m of xy, and we're going to let f of y equal to n of xy, which again is our partial of f in terms of y. So just rewriting this, f of x plus f of y dy dx is equal to 0. That's just replacing with what I just did our substitution for. We're going to take the partial. We're going to take the partial of f of x in terms of x. Partial of f of xy in terms of x. And we'll have to use the chain rule. So using the chain rule, we have f of x, and then you take the derivative of x in terms of x, plus f of y using the chain rule, which is the derivative of y in terms of x, or both in terms of x. So we can see here, we get the same function. Same function. So the derivative in terms of x of f of xy. So the derivative of the function in terms of x is equal to f of x plus f of y dy dx, which is equal to 0, because that's the given equation. So the derivative therefore f of xy is equal to constant is a solution to the dE. You can see that. Integrate dx dx. You get c, and we get f of xy. So testing for exact, this is the same equation. I've just dropped the of xy for m and n, but they can be functions of x and y. We're going to let f of x is equal to m, like above, and f of y equals n. And using the same substitution as above, provided mn, the partial of m, in terms of y and the partial of n in terms of x are all continuous, the theorem above says it's exact. So the theorem above says it's exact if and only if the partial of m in terms of y is equal to partial n in terms of x. Going back to our other notation, this is basically just my is equal to nx. It's the same notation. So basically this is, since my f of x is equal to m, this is my f of x y, and this, since my n is f of y, this is f of y x. You remember those notations from Calc 3. If those are equal, then it's exact. Okay? And we can use either notation, so that's the same thing. So here's the process. So the process is, here's our differential equation. If it's exact, then we find f of x, y, then our general solution is f of x, y is equal to the constant. That's the whole process. Okay? If it's exact, find your function and set it equal to the constant, and that's our solution. Okay, remember, it's our solution because of this. Since the derivative of f has to equal to 0, the function has to equal the constant. Let's just work out an example here. So we're going to solve this dE. We can see here, this is our m, which is also our f of x. This is our n, which is also our f of y. I do think it's best to write both of these because especially in our part 2, we really need to know both. It's helpful. Remember, we want to find f. So this is f of x and f of y. So we want to know if it's exact. So is it exact? I actually think it, I actually like in this place to use f of x, okay, is equal to y to the third, and n is f of y, because then I remember which partial I have to take. It's the other one, okay? It's not f of xx, it's f of xy and f of yx. So now I know I have to take f of xy, which is 3y squared, because it's in terms of y, right? And the second one is f of yx. In terms of x, it's just 3y squared. So yeah, these are exact. So therefore, there exists a function, and we want to find it. So again, we just need to find f, which means that our solution will be f of xy equals c. Okay? So we're going to start off, it actually doesn't matter which one we start off with. We can either start off with f of x or f of y. Typically, we start with the first one. You can practice it both ways to see you'll get the same equation. So f of x, we know, is y to the third. This is the partial. So basically, okay, so this is the partial derivative. So in order to find f, we want to integrate. So i.e., you don't have to rewrite this, but for the first time I will. We have the partial of f in terms of x is equal to y to the third. So if I integrate both sides, and obviously it's going to be in terms of x. So if we started on this side, we'd have to take it in terms of y. So basically, we get f is equal to y to the fourth over, oh, it's in terms of x. Forget that. So in terms of x is y to the third x plus c. But it's not just any constant. Remember, our constant here, I just want to write this to remind us, a constant here, because this is in terms of x, could be in terms of y. So let me just, so f is x y to the third plus constant of y. So we found it, except we don't know what that constant is in terms of y. So we have to be able to find that. So let's keep going. So we've already used this. Now we need to use this one. So basically, now we're going to find f of y. So this is our function, and we want to find the partial in terms of y. So we're taking the derivative now. So the derivative, but in terms of y. X is treated like a constant. So this is 3xy squared plus that is y, so it's the derivative in terms of y. But we also know what f of y is equal to. So f of y, remember, is 3xy squared. Looking at both sides, since 3xy squared is there, what does that tell you, c prime of y? Or you just solve for c prime of y, subtract it, you get c prime of y is equal to 0. So now we have found our constant, just 0. Sorry. It's not just 0. So now we have to find our c of y, not our c prime of y. So we integrate both sides in terms of y. You might already just see it. I mean, that was obvious. Just c of y is obviously just a constant. Integral is 0 plus a constant. So we have our c of y. So my function f of xy is equal to xy to the third plus a constant. We'll have to call that constant 1. And our solution, remember, is f of xy is equal to some constant. So we replace f of xy. It's xy to the third plus constant 1 equals c. Obviously, those constants can get absorbed. It's like integrating both sides and having a constant on both sides. So this is our solution. And we can just box it. A lot of times, these are implicit equations. X's and Y's are all over the place, so our solution is usually written implicitly. This is our general solution. Okay, so we're going to solve the initial value problem where y of 0 is 1. So we do it the same way. Is it exact? This is my m equals f of x. This is my n equals f of y. Again, I will be using both by the next video. F of x equals 3x squared plus 6y, and I'll state f of y, so it's alphabetical order, fx, fy, equals 3y squared plus 6x. So now I'm going to take on the left the f of x, I'm going to take the partial in terms of y. So that zeroes out, so it's just 6. Here I'll take the partial in terms of x. That zeroes out, it's just 6. So yes, therefore exact. So let's go ahead and start off with f of x. F of x is given to be 2. So again, we're taking the integral of f, and we get x to the third divided by 3, x to the third. In terms of x, integrating, it's 6xy plus my constant. I integrated up there in terms of x. So this, my constant, is in terms of y, treated as a constant. So just so we know, this is my solution that I'm looking for. My solution is, again, our solution is f of x, y is equal to some constant. Right? We find that f of x. So we found f of x, except we have to find c of y. So we've got to finish it up. So let's go ahead and find f of y. So we're taking that function and taking the derivative in terms of y, the partial in terms of y. So we get 0 there, 6x here, plus the derivative in terms of y. Now we know what this f of y is. It's right there. Here's my f of y. 3y squared plus 6x. So here you can solve for c prime of y, or we can just look and subtract. See, these get subtracted. So c prime of y equals 3y squared. So c of y, integrating both sides, is y to the third. Now, we could leave out that constant if we want, because we saw last time it got absorbed. But if we want, we can just write this C1 there. You can drop it. You can skip that part right there. Function that I'm looking for is x to the third. My solution, again, it's right here. These get absorbed. But this was an initial value problem. Do believe, yep. So we got to find C. Yeah, all of these zero out when you plug in 0. So my solution, my particular, again, this is my general solution. And my particular solution. And that's it. So we'll do another one. This is my m, which is my f of x. This is my n, which is my f of y. You have to start off asking if it's exact. Partial in terms of y, 6x minus 3y squared. My partial here, since it's y, it's in terms of x. 0, 6x minus, in terms of x, is 3y squared. Yep. Therefore exact. We start with f of x. Find f. So that's the derivative, so I'm integrating in terms of x. Okay, so we found basically our f of x, y, but we need to find our c of y, our constant there first. So it would be find f of y. So now we're differentiating in terms of y. So what is that f of y equal to? This is our f of y, remember? So that's equal to 4y plus 3x squared minus 3xy squared. It looks like this term's the same, this term's the same. So therefore c prime of y is equal to 4y. Integrate, that's the derivative, so we integrate to find c of y. And we're integrating with respect to y, because it's in terms of y. Because it's in terms of y here, not because there's a y there. So that's y squared, 2y squared, plus our c1. Again, it's just going to get absorbed to the other side. If you want to not write it, I'll write it. I like it. Function now, or f of x, y is equal to 3x squared y. Just this, but I'm going to plug in this for c of y. And my general solution And that's it for today.